Right, everyone, this is going to be the last video on this exercise. So there's just a couple more little things that we need to sort of go over before we finish this one up. Now, firstly is this really nice rule here. So if we're doing the variance of ax plus b, then we can actually, well, do a bit of magic on it, I guess, and come out with this here. So this here is an equivalent expression. Okay, and so what that means is it allows us to do these kinds of calculations very easily. So what I'm going to do here is I'm going to write that that's equal to, now it's, a is the number in front of x here, so it's going to be 4 squared times the variance of x, which we know the variance of x from the question, which is 5. So that is 16 times 5, which is just 80. And we can do the same over here. So in this case, the number in front of x is minus 1. So that's equal to minus 1 squared times the variance of x. So minus 1 squared is just 1 multiplied by variance of x, which is 5, and so the answer there is 5. Pretty nice so far. Now that's the last bit on the variance. Okay, there's one more question down here to do with the standard deviation. So in batches of 100 eggs from a farm, it is found that typically 8, that is an 8, just in case you're wondering, have cracks. It is known that the standard deviation for the number of cracked eggs is 3. Between which two values would you predict 90% of the number of cracked eggs to fall? So, you know, in one batch we might have, say, 9, and in another batch we might have 6, and blah, 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 okay? Now this here goes back to your normal distributions, okay? And you might have heard of something called the 68, 95, 99.7 rule. Okay, and this is to do with standard deviation. So what it says is that 68% of the scores, approximately, so approximately 68% of the scores lie within one standard deviation of the mean, 95% of the scores, approximately, lie within 2 standard deviations of the mean, and 99.7% of scores, approximately, lie within 3 standard deviations of the mean. So I think for the purpose of this course, you only need to really worry about the 95%. That's the methods thing. You know, they don't sort of go outside of that much that I'm aware of. So, you know, just know that 95% of scores fall within 2 standard deviations of the mean. What that means is the probability that mu minus 2 standard deviations is less than or equal to x is less than or equal to mu plus 2 standard deviations is approximately equal to 0.95. So, well, this gives us a pretty good idea of what we can do. So we know that there are typically 8 eggs that have cracks. So that's the expected value. We know that mu in this case, or the expected value, is equal to 8. We also know that the standard deviation is equal to 3. So if we go mu minus 2 times the standard deviation, that means we've got 8 minus 2 times 3 less than or equal to x less than or equal to 8 plus 2 times 3. And again, that's approximately equal to 0.95. So then it's just a matter of figuring that out. That is the probability that now 8 minus 6 is just 2 is less than or equal to x less than or equal to, and that's 8 plus 6, which is 14, is approximately equal to 0.95. So therefore, we expect between 2 and 14 cracked eggs (95% of the time). And there you have it. So that is the expected value, the variance, and the standard deviation. I'll leave it there and see you in the next video.